Good afternoon. On behalf of Engineers Australia, I'm delighted to welcome you all to our Thought Leaders series, Eco-Friendly Riverbank Protection Systems. My name is Amanda and I'll be your host for today. Firstly, in keeping with our custom, Engineers Australia acknowledges the traditional custodians of the country throughout Australia and recognises their continuing connection to land, waters and community. We pay our respects to them, their cultures, and to elders, past, present, and emerging. Before we get started, I'd like to acknowledge that today's webinar is being hosted with Engineers Australia's industry partner, Geofabrics. Geofabrics is an Australasia's geosynthesis specialist. They help their clients deliver and maintain infrastructure by minimising risk and increasing value through the innovative use of geosynthetic products. Geofabrics have supported the Australasian infrastructure sector on significant projects from the Victorian level crossing removal to APLNG in Queensland to the Christchurch gondola in New Zealand. On these projects and every project they undertake, Geofabrics have a singular focus to provide smarter infrastructure solutions. Today, we will hear from two speakers, followed by a live audience Q&A, and I encourage you to send questions through to our speakers via the chat box. I'd now like to welcome our first speaker, Dale Chachak. Dale is the National Business Development Manager of Slopes and Walls and received his civil engineering degree from Durban University of Technology, South Africa. Dale has over 24 years of technical experience with the design and use of geosynthetics in South Africa and Australia, with area of expertise including retaining structures, slope stability, hydraulic structures, and rockfall protection. Please welcome Dale Chachak.
Thank you for the introduction, Amanda. Hi everyone, this presentation is an introduction to river works and to basic principles to take into consideration when designing river engineering structures. I'm going to start with a brief introduction to basic principles in river engineering. I'll then move on to typical solutions and their functions, and then I'll give an overview of the Macra systems used and the important features and benefits. Let us begin with river works, basic principles. The first postulate we shall keep in mind is that hydraulics is not a science. When we design structures and river works, we base our choice on theories, but also on experience, on know-how, and on best management practices, assuming that the effects of nature, being rainfall, flooding, storms, etc., are available from statistical data. This requires our approach to do a risk assessment, analyzing scenarios beyond the data assumed. We can identify three main scenarios in our river engineering practice. The planning scenario, that is when a new situation is under design, new urbanization or rehabilitation of an existing drainage channel, etc. Remediation scenario, when riverbanks are subject to or about to undergo a potential landslip. We intervene to prevent further instability or to fix or reprofile an unstable slope. Emergency scenario, particularly relevant is promptness and effectiveness. It has a high value because failures may result in loss of property or life. River engineering requires to start from the location and characteristic of a watercourse if we are on the mountains, or at the foothills being mid-slope, or in the valley close to the river outlet. The three regions will be characterized by different climates, different soils, and by different morphology. In mountainous regions, watercourses will be characterized by steep gradients, 5 to 10%, with deep erosion frequency characterized by abundant and coarse bed load. Structures used to prevent erosion in these regions are grade control weirs, sometimes combined with secondary longitudinal bank protections. On the mid-slopes, gradients become moderate, say 1 to 5%, and river sections start widening, forming a low-flow section and a berm on the lateral sides, which will overflow during the high floods only. In dry times, sometimes forming small islands or rapids and short reaches. Typical structures may still be Gabion weirs with a wider crest combined with bank protections alongside and small groins to facilitate sedimentation on curved reaches. Valley regions are the last segments of our river where the watershed has collected most part of the rainfall volume. Rivers are typically characterized by low gradients less than 1%, low velocities less than 3 meters per second, and large discharges, sometimes more than 1,000 cubic meters per second, and by tendency to meander. Interventions in this region will be primarily to stabilize the riverbanks, or bends or straight reaches, and to favor sedimentation in sections where the meandering tends to progress. Understanding rules means to understand the cause of erosion. We could start from the type of problem, then see what is the cause and where it is generated, and finally what effects result from such a type of problem. We could have drainage resulting in surface runoff, typically occurring on natural or artificial slopes, and finally generating erosion due to lack of vegetation and soil instability. Another type of problem is seepage, resulting in reduced soil strength, wear in embankments and slopes. Another problem is scour, formation of scour holes at the toe of riverbanks, critical for bridge abutments, generating progressive instability. Finally, wet and dry cycles or temperature variations, resulting in the formation of cracks and cohesive slopes, resulting in progressive erosion. When it comes to which type of protection is most appropriate, we shall not forget that installation, whether above water or below the waterline, will play an important role in the choice of solution. Above water in dry conditions, we have a wider choice, from light revetments to hard armor, heavy-duty linings like Reno mattresses or Gabions. Below the water, the use of special equipment and sometimes divers to assist, plus the inability to connect units with each other underwater, will limit the choice due to the requirement to deploy units fast and easy. In most cases, things like Gabions, Reno mattresses, even sack Gabions launched by crane and or by barge. Furthermore, when erosion on slopes is the cause of geotechnical instability, retaining structures shall be used. Gabions or Terramesh mechanically stabilized earth walls can be used, most likely with Reno mattress apron as a toe protection. However, since Terramesh requires proper soil compaction behind the rock-filled face, installation should be made in dry conditions. On the contrary, Gabions and Reno mattresses are allowed to be launched as individual or multiple units under the water surface. The example on the slide shows us how the urbanization effects can change the way the same rainfall event will affect the watercourse. The two plans show the same river section in 1970 and after 9 years, after urbanization on the lower side. The construction of the new road, the housing development, and the drainage and permeable surface, etc., have drastically reduced the time of concentration over the years. As a result, the same volume of rainfall precipitation, only a few years now, generates a peak discharge much higher than before. Erosion protection systems shall be designed considering the flood duration and will depend on the type of watercourse. For small rivers or drainage channels, we shall consider a few hours for the duration of the peak flood. For medium-sized rivers, say 10 to 30 meters wide, flood durations may be in the region of 10 to 24 hours. Larger rivers can easily reach flood durations above 24 hours till few days. Along with the different flood durations, the effects of time will also be crucial during the life of the river, as vegetation will change the flow conveyance in the river section. A correct design shall include an evaluation of how vegetation will affect that flow conveyance over time. An example of this is shown in the small channel section where vegetation has successfully taken over after some years, but this resulted in a change of flow conveyance as well. Similarly, the application shown here on the right is a retaining structure combined with soil bioengineering to accelerate natural recovery. After 11 years, banks are totally integrated and natural, but conveyance shall also be considered to ensure that floods are still contained within the river section. Let us now look at the solutions and their main functions. Erosion protection systems in rivers can be grouped together depending on their direction to the stream, lengthwise or crosswise, meaning along or across the riverbank to prevent instability, or by conveying the flow as drainage media. In the first category, we shall consider bank protections and bridge abutments. In the second category, we can group river crossings and culvert headwalls, as well as the special guide buns, more typical of very large rivers like those found in India and China, or bridge piers. In the third category, we can group channelized streams or reaches where rivers are canalized due to the space constraints, typically when water courses cross urban areas. And lastly, in the fourth category, we group large watercourses flowing in plain regions where the main aspects are to control the meandering effect, typically using groins. Along the banks, rivers generate instability by eroding the toe and creating a failure surface. Solutions in this category combine gabions or Reno mattresses depending on the angle of the slope. When infrastructure cross rivers, we shall ensure that the bridge has a stable foundation. We can see examples of progressive erosion underneath the bridge due to lack of protection. On the right side, examples of how the main structure is protected using these gabions and Reno mattresses. Another example of lack of protection could be culvert structures. Here, the main contributing factor to progressive erosion is the rigid apron, unable to follow the soil contours. A correct design shall consider flexible systems used to manage the transition zone between concrete being rigid and soil being loose and erodible. Special applications are guide bunds, which are structures that divert the water to flow in the central zone of the river. Here, foundations and highly erodible riverbeds can be subject to instability as piles are progressively exposed to the flow. These situations are quite critical as we have rigid supporting elements, being the piles, in contact with loose erodible soil. Again, gabions and Reno mattresses as flexible erosion protection works manage this transition zone to avoid abrupt changes. Drainage channels, like channelized streams, collect and convey water to a safe zone. Protection measures in these courses guarantee that the flow is safely brought to the delivery network. In large floodplains, normally the groundwater flow as well as the secondary channels may affect the flow in the main channel section, sometimes forcing changes in its path. Considering that floodplains or areas adjacent to the main channel are often used for agricultural purposes in the dry season, gabions and mattresses may be used to contain the flow inside a desired section. Often in wide river sections, typically in alluvial plains where meandering can be dangerous as it could progressively scour close to the infrastructure, groins may be used to favor sedimentation in the outer reaches of the bend. Lateral spillways are used to provide a controlled water release, diverting the water from the river during the flood or redirecting the water back into the river after the peak flood. Spillways release water to prevent damage to the levee embankment. Except during the high flow event, the water does not flow over the spillway. Spillways can be constructed with the crest lower than the top of the embankment. The protection is usually made by concrete, stones, rocks, or gabions. Overflow spillways with significant hydraulic head will require a properly shaped crest as energy dissipator downstream and a protected release channel. Let us now see some important features and benefits of gabions and Reno mattresses. We will start off with some basic definitions. Gabions are flexible cages made of hexagonal double-twisted woven wire mesh. The wire is Gelmac, a zinc aluminium alloy, coated mild steel with an additional high-performance Polymac polymer coating. Polymac coated units are highly recommended for hydraulic-type applications. These units are laced together, packed with selected stone and act as building blocks. They are used in the construction of retaining walls, weirs, culverts, inlets and outlets, and other civil structures. Reno mattresses are thin, flexible cages, less than 500 mm thick. The mattresses are divided into cells by diaphragms positioned at 1 meter centers. The base of the mattress and the diaphragms are made from one continuous mesh panel to aid in rock confinement. They are used mainly in channel linings, revetments, and scour protections. We shall say that double-twisted mesh products are suitable for river applications for their 4 main features and benefits: flexibility, filtration and permeability, durability, and environmental compatibility. Rigid structures, although resistant to high forces, are not suitable to conform to soil contours. On the contrary, flexible structures allow the structure to keep contact with the soil underneath, maintaining the protective function over time. Filtration is also very important in river environments as they allow a natural exchange of water from and to the soil behind or below the structure. In a river environment, we shall guarantee the longest durability, considering the effects of the flowing water on the wire. In the presence of water, international regulations are becoming more restrictive and do not allow metallic coatings only. An additional polymer coating is necessary to provide life expectancy. This table shows the assumed values of durability based on testing, accelerated aging, and experience. Here, nature has taken its course. Where the old Gabions and Reno mattresses were installed, we see today just a river with its stable banks, vegetation, shaded spots, fresh water, local fauna, etc. The ecosystem is re-established. Gabions are part of this and continue to work hidden under the vegetation. Particularly interesting is this example, a tree that has grown through the rocks and steel wire mesh, engulfing the steel and rocks as part of the trunk. Rather difficult to figure out how this could happen. However, quite logical considering that the tree grew through the years from a little stem to a tree year after year, finding its way out from the ground and under the Gabion to the surface, each year expanding and engulfing the stones and rocks as part of its nature has taken its course. The second concept is we shall introduce minimal disturbance. This means that we shall apply engineering systems with a correct balance between technical soundness and minimal amount of environmental impact. Erosion protection systems start from light linings to a rolled form like geomats or biodegradable mats, combined with soil bioengineering techniques like fascines, willows, brush mattresses, etc., to heavy-duty lining systems like Gabions or Reno mattresses, up to heavier massive retaining systems like Gabion walls or mechanically stabilized earth structures. All this under the common denominator to meet the requirement of a sound design using an engineered solution. Thank you.
Thank you, Dale, for your presentation. I'd now like to welcome our second speaker, Paulo DiPietro. Paulo is currently Senior Technical Education and Know-How Manager at Office C in Macra Corporate Headquarters in Bologna, Italy. Since 2001, Paulo has held frequent seminars and workshops to assist design engineers, contractors, and state officials in geotechnical soil retaining structures, slope stabilization, river and erosion control works, and best managed practices of soil bioengineering systems. Paulo is also an active contributor to the development of international standards and author of several papers at international conferences. Please welcome Paulo DiPietro.
Okay, thank you, Amanda. And hi, everyone. In this presentation, I give you an overview of recent research studies and on the engineering aspects about the use of environmentally friendly and natural solutions to protect the rivers against scour and erosion. Well, I'm going to introduce firstly a brief historical background about our company over the decades until today. Then a brief introduction as well on typical solutions used and their functions. Then speak about the main highlights, which is the core of this presentation of a recent research study on the performance against high flow regimes of a new generation rockfill mattress, which we call the Reno Mattress Plus. Then we'll have an overview of a new user-friendly software online. It's a web-based application. And lastly, a few words about how the environmental aspects are taken into a modern design practice of river engineering. The first application of Macra was built more than 130 years ago along the River Reno, crossing a small town in the outskirts of Bologna. You can see from the map up on the right side the location in our little country in Italy on the Western world. This early application, built in 1894, repaired the banks due to a breach caused by a flooding. The structure is a first example of steel wire mesh used to confine natural rock to reduce their volume. A simple idea revealed to be successful over the time. The successful performance of this first application encouraged Macra to further develop steel wire mesh gabions with the box shape to allow them to be connected together to form monolithic structures. At the beginning of last century, Macaferri develops the idea of manufacturing the mesh by double twisting the wires to provide an improved strength through the hexagonal shape. In the following years, Gabion's or Gabion applications in general start becoming attractive as erosion control systems due to the use of the natural materials, since they combine the strength and the flexibility with a natural, pleasing look. There's increasing interest for these natural systems and their environmental friendliness and ability to integrate with the surrounding environment motivates the company Macaferri to invest in research in programs aimed at developing an engineering approach through the design criteria. Well, this is where we are today, developing a simple idea over the decades, to say over the century, by the way. Macaferri then evolves into an industrial group with a presence worldwide in many countries and locations. This picture is a world map of our presence, operations, technical, sales offices, a bit everywhere. And this is where we are mainly involved with, in our engineering fields, where Macaferri offers today environmentally friendly solutions, spanning from the mountains, from mountainous sites, rockfall protection works, to geotechnical applications like walls, embankments, pavements, tunneling, even. And then moving to the hydraulic applications, which is the subject of today, rivers, channels, dams, or even coastal protection, onshore, in ports, in harbors, and even in offshore underwater applications. Solutions for all these fields with a close commitment to the sustainability and the respect for the environment, a fundamental part in our mission. For key and strategic projects, Macaferri offers today also collaborations and expertise as a technological partner. The role requires a product portfolio to complement, let's say, widely our core product lines. Well, coming back to the rivers, in river environments based on concepts illustrated earlier, the solutions are typically based on location and characteristics of a watercourse. Maybe I'll say something a little obvious to some of you, but that's very important to start from the principles. In the mountains or at the foothill of a slope or in a valley close to the river outlet. So the three regions are fundamental to be distinguished, to be characterized by different climates, different soils, and by different morphologies, of course. In the mountains, the watercourses typically are characterized by steep gradients with deep erosion and an abundant and coarse bedload. So the structures in these cases are typically grade control structures like weirs combined with longitudinal protections. On mid-slopes, gradients become moderate and the river starts widening. And that is where we form low flow sections and the berm on the lateral sides. So here again, wider rivers, wider weirs, and say protections on the side. Typical structures, again, like I said, combine the bank protections and sometimes with small groins to facilitate the sedimentations on the bands. Lastly, in the valley regions, the watershed has collected most part of the rainfall volume. Rivers are typically characterized by low gradients, low velocities, but large discharges. Interventions will be to stabilize the riverbank and to favor the sedimentations in sections where the meandering tends to progress. Stabilization systems can be classified as linings, blankets, mats, rolled products, rock-filled mattresses, and earth retaining structures, as you can see here in the categories. The functions on the earth, let's say on the lining, firstly, is to protect the surface against the erosive effects, while the function of an earth retaining structures is twofold, actually. Protect the river against the surface erosion, as well as to protect against the geotechnical instability. We have here Gabion retaining walls in the case of earth, or mechanically stabilized earth walls like our Terra mesh, for instance. It is important to select the type of intervention for its required function. This is to ensure that the project conditions are suitable for that solutions. Linings are subdivided into soft armor like geomats or hard armor, which sometimes are even called the heavy duty type, like the rock-filled mattresses. Soft linings favor the re-establishment of a solid and stable vegetation layer. That's their function. While on the opposite, the heavy-duty types provide the stability by weight. Soft linings are used along the riverbanks, for example, with moderate or low flow regimes, or in the upper part of a bank where the velocities and the exposure to erosion during flood is limited. Their ability to establish vegetation in a short time will be fundamental. While on the opposite, in earth retaining structures, they are used for erosive effects in the water, but also in the protection of a large portion of the soil and to avoid the bank to collapse. But now let's go quickly down into the research studies, because there is quite an interesting development here that I'd like to present to you today. Let's see the performance limit of a new mattress. Well, in the hydraulics of open channels, an important change over the years has been the creation of a standard. The first research on Macra mattresses dates back in the 80s, in 1984. At the time, there were no rules about erosion protection systems. So the only real design criteria for rock-based erosion systems was the theory of the attractive force through the use of the shield parameter. The mattress stability was based on the principle that the confined rock shall not move. The development of several light erosion protection products over the decades required guidance for their selection to be able to test and compare their effectiveness. So the first international standard defining the performance limit of erosion protection systems comes in the United States for open channels and is ASTM coded D6460. It's a fundamental achievement because this standard finally states a guideline applicable to all types of erosion protection systems. The standard defines the stability of a lining when either no collapse or erosion happens underneath. The research which we undertook at Colorado State University, that was in 2019 through 2020, was developed in three fundamental steps or tasks, as we can call. The first, we can see on the right side of the screen, was preliminary and aimed at analyzing the effect of the flow on the wire mesh and the type of partitions only. So to this purpose, the test was performed running the flow on an empty mattress. The scope was to see how much resistance to the flow would the wire mesh alone provide. The second step, that's one in the middle, was together and combined, was always preliminary, were made filling mattresses with rock of different gradings and uniformity. Here, the combined presence of the different partitions of stones allowed to test the velocity dissipation through the mattress layer. That was another fundamental point, preliminary. And then we moved into the last and final and most important test, which is the full scale. That was made on a larger flume, simulating real flow regimes of an open channel. Based on the results on this preliminary investigation, then we did the testing with the best performing combination of partition, stones, and sizes. Well, the full-scale tests on the new mattress type were performed in line with the ASTM D6460. defining failure either by occurrence of a mechanical rupture, as I said, or stone motion, or by reaching the excessive erosion under the mattress. We can see on the little here side, I don't know if we managed to see a little video that's showing the power of the flow during the testing. Well, the new mattress compared to the old type has a partition made by pleating the wire mesh and connecting the lower corners in production. It has a special vertical tie connecting the top to the bottom. And this is providing a tight and uniform confinement to the rocks. This is shown in the schematic bottom here that you can see here at the bottom right. At the bottom, say left and right, so old and new. Ultimately, the steel wire mesh is coated with a high abrasion resistant polymer coating, a new generation with a performance, 10 times stronger than conventional PVC. Well, comparing past and present research, so from the 80s till today, between old and new rockfill mattress types, we can say certainly something important of what we learned. In 1984, the first experimental study at CSU, so Colorado State, performance characteristics and the design criteria for Reno mattress with a single diaphragm, no ties, were focused on the conditions of incipient motion for the rock based on tractive force. However, the development through the years of the products, along with decades of successful experiences, of course, with product development with mattresses, and lastly, the creation of this new standard that I mentioned, introduced a new way of looking at looking at the stability, combining requirements of mechanical resistance with those of having limited erosion, soil and soil loss under. So the chart that you can see here on this slide shows a summary of past and present, where you can see the improvement in performance of the new generation mattresses when testing mechanical stability and erosion protection. And for instance, in the light blue bars that you can see up here on the chart, they represent the results of the old mattress tested in 1984. The blue middle bars show the increase in shear strength stability when using double pleat diaphragm and best grading for the fill. Well, in the dark blue, you can see the ultimate and most relevant increase in the shear strength when adding the connections, the X ties. So overall, we speak of an over 50% increase in performance through the product development and a better way of testing materials. The new Reno Mattress Plus with the X ties has three main improvements compared to the old type. The pleating, as I mentioned, the innovation, which is innovative and more durable new polymer coating, because this is an extremely important point, making the wire more resistant to the typical phenomena in rivers, the abrasion, abrasive effects, or UV resistance to high temperatures, as well as a lower embrittlement temperature in the cold climate. And third is the X tie, this firmly and securely element to connect lid to the bottom of the mattress. The X ties are freestanding tools, so they are easy to install. In summary, the research study on the full-scale model in Colorado was a very extremely interesting experience, because we learned that the resistance of a new mattress does not depend just on size and weight of the stone fill, but in other important parameters, as we see here, the uniformity of the stone fill, the mattress thickness, the number of stone layers that we're going to put on top of each other, the type of mattress partition, so pleating or single, and finally, the connection between top and bottom to keep an adhesion, say a strong confining effect to the rock. All fundamental points which made us develop a new design approach. Obviously, and for simplicity, a new design approach can be keyed into a software. And here is what we're going to talk about. the new Macra design. Well, the results of our research have been implemented in this web-based application. Macra design stands for Macra River Analysis. This is very general. As you can see from this slide, we deal with channel and bank protections as well as in grade control structures. The software allows to a wide range of applications, natural or artificial watercourses. The advantage of a web-based application is twofold: easy and free access, because you can resist it free of any obligation, and always updated, never expiring, because we continuously improve the software through the use of it. The Macra design runs analysis of channel sections in uniform flow. It's simple in the principle. The software allows to select the material in each segment of from a database of materials available. The same database includes mattresses, gabions among the erosion protection systems, providing their performance characteristics in terms of shear stress, shear resistance to the flow. Well, as you can see here, this is taken from literature. As discussed in the literature in the hydraulics of an open channel, the shear stress, the approach of shear stress, represents a much more realistic model of detachment and erosion processes rather than velocities. Literature shows, in fact, how different the velocity distribution can be in a channel section, especially with different and relevant roughness values on the channel for the channel banks. You can see here you can have differences even between twice the average velocity in a channel in the section, as well as down to 0.5 times, so half of the velocity of the average velocities close to the channel walls. Well, a quick representation of the attractive force shows us how erosion generates and which by motion of soil particles, which is basically by motion of soil particles along the stream, and for which the conditions of stability is achieved when the resisting shear force tau C is greater than the active shear tau B. The results implemented into the new Macra design have been, let's say, keyed in fairly easily. The software has a facilitated data entry. The app provides a selection of multiple templates of channel sections to start with. The designer can adjust the geometry, assigning real dimensions and slope angles to each segment. Here you can see the templates. In the next slides, for brevity of time, I will just give you a brief introduction on how the app works. Obviously, should you be interested in learning more about this app and its features, we provide regular tutorial sessions on the use of the software. You just need to provide your data and the chat box, and we will get back to you with the first available dates. With Macra design, you'll be able to model channels of any shape, from simple, rectangular, to trapezoidal, to double trapezoidal, or eventually other sections as well. Changing the geometry and reshaping sections and checking multiple discharges, as well as profiling slope hardly with natural vegetation or etc., will be very simple to do. Let's now move through the menus and see how the software easily can guide us towards a solution. So when we go to a channel, we have initially, as I said, we start from a template, and we have on the left side on the screen the data to enter. We got hydraulic data where the user is required to enter whether he wants an automated discharge or a given discharge that's part of the project, and then define what's a freeboard is, longitudinal slope, to give a grading to the channel. Then later on down, there is the geometry tab. On the geometry, the user will be able to adjust, model the size of the section, changing sloping angles, as well as length, etc. The last and most important part is the access to the database. each single stretch will be able to be designed with a specific material. By clicking on the Choose Materials, the user will be able to enter our database, where it will be possible to use either natural materials. In this case, we've opened the window where the mattresses are, and on the mattresses, the user will be able to see selecting thickness, the rock size, the uniformity ratio, and then the software will pick from the database the right shear allowable stress for the design. Moving on to the next, running on the right hand side, right top hand side of the screen, the user will see the results of the calculation with a few tabs down at the bottom. As you can see here, you will see the water level, but then you see down at the bottom here the discharge, which you'll access by clicking on the relative tab. Discharge will be the chart will show you um, by moving the cursors along the curve, you'll be able to see what level of discharge can be released at that level of elevation, as well as on top of here, you'll see the full discharge for the full section over the longitudinal slope of such and the water depth. Again, moving down to the next tab, you'll see on the materials, and there will be the checks giving you whether the section or that stretch of the channel section will be stable. As you can see here, they're all checked, and where you have the calculated shear stresses on the, say, right column shear stress in newtons per square meter against the allowed. So you'll see that all the numbers on the allowed are above the calculated actual shear stress developed. The next and last page is a summary of all calculations, showing you in the three parts, similarly to what HECRAS, if you're familiar with the software done by the US Army Corps of Engineers, dividing in left, main, and right overbank. So left and right overbank, which are fundamental for the double trapezoidal sections and on the areas where you have berms, and the main channel sections, and to see the differences in between the various parts of the section. Moving down to the next, which is grade control structures. Well, the second app in macro design is about, as I said, grade control structures. Here, the main functions of grade control structures is to reduce the riverbed gradient. You have an delta X, you have an L, and then the ratio between the two gives you the gradient, okay? By creating a zone downstream each step where part of the total energy is dissipated, in a concentrated zone, we have the possibility to change the gradient from I to I star, and this will generate a reduction in the erosion processes. Gradient reduction implies a reduction in velocity and then lesser erosion in the channel. Here again, the software is coming into us to help us in the making the choices. We have different types of drop structures, from simple vertical drops to stepped weirs, which are drop structures basically, and finally to spillway chutes that we can design. As we move into the vertical drops, we have a number of aspects to take into account. The design of a weir requires to properly size several components, ranging from the weir's main body, the wings, the longitudinal walls running along the top of the banks downstream, and finally a steering basing, either with an unlined or a lined protections like this image. All checks have to address both hydraulic and geotechnical stability. So let's see the vertical drops. For vertical drops and for brevity of time, as I said earlier, I won't be able to take you through all the menus, but like I said, the tutorial session, in case you're interested, will be always available to you. But it's very easy and user-friendly. While we have in the hydraulic data, channel geometry and weir geometry, possibility to enter all the elements. Once we run the calculations, we'll be able to see what you see here. First of all, the cross section with the water level. And then moving into the next tabs on hydraulic results, you will be able to see all the parameters for the hydraulic calculations, how much scour is generated downstream the drop, what is, if there is a need for a stealing basing, what the distance of that, etc. And this will actually be into the next, sorry, in the next tab. So I was too fast, jumped into the next. And finally, you'll be able also to see from the statics point of view, because in the end, we're building a wall into the stream and we need to design, say, traditional checks are sliding, overturning, etc., like a conventional retaining wall. But not to forget also the hydraulics, because we have seepage through the structures, and the possibility to have a permeable structure will give us an extremely good advantage, because the structure will be able to, say, support a lesser amount of forces around because of the possibility to permeate. The next is the step structure. And this is also another, say, fairly common type of structures, especially on the outflow of culverts and in many situations, especially in conjunction with, say, um, roads or situations where we're conveying from valley sides and we want to dissipate the energy. Here, in this case, we're basically calculating in between two typical hydraulic phenomena, the skimming flow and nap flow. There's been, in this case, the software is able to tell us what kind of regime we have developed in these conditions, what's based on the geometry we've assigned, and then we will be able to see from the basing point of view whether the shear stress generated by a given lining, especially at the bottom, at the basing point of view, uh, if it is acceptable or if it needs to be strengthened with, say, more layer of rock or anything. Finally, this last application, the last app, is on the the spillways. And here again, we have, based on the most recent studies, the possibility to determine, and this is actually very interesting. I'd like to show you here in the last graph of the calculations, you'll be able to see what level of resistance we are going to provide based on the increased shear that we develop through the spillway. As you can see, moving away from the top of the crest, which is the zero side on the abscissa, moving into the final of the erosion at the distance away from the crest, we will see that in this case, for this example, the green line represents what we have, the green, say, horizontal line is the kind of resistance that we provided with our mattresses. I'd like to say a couple of words as well on another subject that very recent. I'd like to mention here a subject that belongs to specific and the challenging world of installations under the water, erosion systems underwater. Well, that's common knowledge that, as we all know, that in this subject, in the last decades, cargo or touristic ships for marine transport have become larger and deeper to answer demand of the market, while marine transportation still remains one of the most economic ways for economic and social growth of our world. Well, a consequence of this growth in marine transportation led to the inevitable increased size of the propellers and the ships, which can lead to an increased erosion right close to the vicinity of the quay wall. So after the Colorado testing on the flume, full scale, as you have seen also in terms of high shear stress in high flow regimes, we participated to a further research study aimed at this time at validating results by flume testing with forces generated by most powerful jet propellers. It was quite an interesting experience. This study was part of an ongoing research project done at Deltares in Delft in the Netherlands. The rock-filled mattress, in this case, added several additional components to make it specifically suitable, as you can see on the picture here on the right side, on the left side. The new type of pre-filled mattress was made, in fact, by adding an additional geotextile underneath and the wire mesh panel, additional, attached, all together with other components like lifting bars specifically designed to lift in safety these units and maintain them very straight and uniform, no movement of rock during launching operations. Well, the results from Deltares studies provided an indication of the actual velocities generated by these propellers on the mattress surface. They confirmed that they were within the design allowable parameters that we've achieved during the flume tests in Colorado. So it's quite an interesting finding. Well, based on these two research studies in line with current guidelines, which is for the erosion due to jet propeller scour and is PIANC report 180, the thickness of a suitable protection against the jet propeller scour could be calculated using the formula that you see here, proposed by Christian Pilarczyk, where the parameters shown here allow to determine the minimum thickness of a protection to guarantee stability against the action of propellers. So using results of these tests at Deltares, we obtained just to give an idea, that the 30 centimeter mattress, or call it Renomac, the unit for the underwater, is equivalent to approximately 1.5 to 1.8 meters of reprop protection. So quite a considerable saving if we consider that in most cases, dredging is one of the, say, most labor-intensive operations and costly operations. So we've learned a lot, and I'd like just to quickly draw some conclusions. There are considerable benefits using these modern technologies made by using more effective natural materials. Let's see them very quickly. The use of an engineered system, yes, because we've tested it. Second of all, material saving, because we have, say, really a cost, say, a reasonable, high cost effective. Look at the numbers, so over 60% of stone saving. We have speed of constructions, because by using less material, we also have less operations in the field. We also have less dredging works, and that's another fundamental point. That's one of the things that for the construction of a protection is one of the most costly operations as well. We have no waste of material, because when we're dumping rock, we never know exactly how much quantity we need to fulfill the project requirements. When it's say a given surface to cover with a unit that has a specific size, you know it. And finally, and not less importantly, we have less environmental burden. That is another important point, because that goes back to what is in part of the UN, say, sustainable goals, the number 14. So in the principle, that takes me to the last topic, because speaking of environment is fundamental also to keep in mind some considerations. The first consideration is a concept of sustainability, because this is a word that we hear very often, but what is exactly in the definitions a term that, say, is appropriate for sustainability? Well, UN defines sustainable development as the development that meets the needs of the present without compromising ability of future generations to meet their own needs. So that's a fundamental point, because while traditional engineering in this area, design is focused only and mainly on the functional cost and safety. Sustainable engineering actually is about designing in addition to consider the impact of the design on the society and on the environment. For an engineering design to be sustainable, the competing requirements of three pillars fundamental are environment, economy, and society, and they need to be balanced. So sustainable is at the junction of these three fundamental pillars. And this takes us to another important concept, what we call life cycle assessment, LCA, that we hear all the time. Well, this is a fundamental point because a methodology for assessing environmental impact associated with all stages of the life cycle shall take into account what we call circular sustainability. So there are several steps in defining what environmental sustainability is. We have the raw material supply, we have the manufacturing process, we have transport, its use, the disposal and recycle. So everything makes part of a fundamental, say, life cycle assessment. And we're very much committed into this. An inventory of materials, energy, emissions, they are involved in the product, processes, and services. This is what, again, we define by sustainability and where we believe in. So by saying this, I'd like to then take to the last part, which is the definition of environmental compatibility. So there are some considerations in the modern and correct approach to river engineering. I think we need to recognize two main types of requirements. The hydraulic requirements, meaning the base of technical knowledge. Okay, this is what we've discussed so far. This includes evaluating the stability of a solution, both from geotechnical and from the hydraulic point of view. But then we have the use of correct and sound engineering practices, of course. We talked about ASTM standard, testing, etc. And finally, a design method which is appropriate and based on the risk assessment. So our software allowing to design the what-if scenarios. This is a fundamental point. Lastly is to consider erosion as a natural effect. So will affect on the surrounding environment. So use an integrated river management approach. But then we need not to forget the environmental requirements. What do we mean by that? Well, first of all, is we need to consider that the river is a living environment. So it will evolve over time, it will change, and it is necessary to consider that it will change over time. When we speak about the time factor, you've heard in the previous presentation, when we speak about elements that are fundamental to reestablish nature as it is, in applying the river engineering principles, minimizing changing in the morphology and the nature of the watercourse, not straightening a river, but assuming that life will need to regenerate, using protection measures with a proven ability to recover, so to establish the natural conditions, that is, using sustainable systems, and finally, providing solutions aimed at balancing the ecosystem. So let's see them one by one. There are four paradigms we said about the environmental. The first one is river as a dynamic environment. So meaningful examples in nature show us how Mother Nature evolves in a river environment. You've seen it in our oldest project site. So this is the picture showing on the left side the oldest Gabion structures in Italy built in 1894. On the right is the same river 130 years later. As you can see, the nature has taken over. But then there's the second paradigm is introducing minimal disturbance. So the second concept is introducing means that we shall apply the engineering systems with a correct balance between technical soundness and minimal amount of environmental impact. You see here along the scale from left to right how we change the solutions based on a certain environmental impact, okay, from low to medium, medium to high. When do we need to use low? It's not the site where we need to use high. And so this is the decision at the engineer level is very fundamental in this point. Choosing the proper system to introduce the minimal disturbance in line with what the engineering requirements are. The third principle, as I said earlier, is implementing sustainability. Well, this requires to look at level of environmental sensitiveness of the site. Well, are we in a park, in a river, in a recreation zone? Definitions of recognition of the location is fundamental. We need to use structures suitable to provide the hospitable conditions for the native plants to establish. And then to ensure that the solution will meet the engineering requirements to reduce velocities near the banks. Lastly is to ensure the soil bioengineering practices are implemented properly and they will fit with the local ecosystem, and developing a solid root network to reinforce the soil. The fourth and last requirement is to balance the ecosystem. In a river section, we can recognize different areas. I took this schematic from one of the, of the USDA's, the United States Department of Agriculture, who have published books in the past. And it's a quite representative idea. It gives us a representative idea on how life develops around the river. River is life by itself, by definition, and we know this, we can recognize this. So we need to balance the ecosystem, knowing that in a river section we recognize different areas where the nature and the surrounding ecosystems develop. And that is the last part, in which I believe is fundamental part of our mission. So recognizing, using natural materials in rivers at the most, as much as we can, and have a history behind us that motivates and gives us, our commitment to meet, the targets of the future. This concludes my presentation, and thank you for your attention. Of course, we will be here available for questions.
Thank you. Thank you to Dale and Paolo for those great presentations. But always, it's now your turn to get involved. Could you please ask our questions via the YouTube chat box and who your question is directed to? Thank you to everyone who submitted questions whilst registering, and we might start with starting with a question to you, Dale, that's coming from Maria, who is watching from Canberra. Good afternoon to you. Asking you, Dale, with the increase in flood levels, how can we plan for river protection systems? Thank you, Dale.
Well, a hydrological analysis is essential for understanding natural flow paths, rainfall intensity, drainage patterns, and flood risks. Flow paths do change, as we would have seen in the presentation, due to name few, urbanization and changes in flow conveyance in a river section. And it's important to take these changes into consideration. The hydrological analysis helps to identify areas prone to erosion as well as sedimentation, and therefore gives us the opportunity to design appropriate protection structures.
Thank you. Thank you for that, Dale. And Paolo, bringing you into the discussion that we've had. So, Dale, we have a question for you that's coming from Jeffrey, and Jeffrey is watching us from Queensland this afternoon. Asking you, Dale, do you have examples along the Mary River?
I don't recall any examples on the Mary River itself, but I do know of a number of Gabion and Reno mattress structures around the Maryborough region. We would, however, be more than keen to assist if you're considering a hydraulic type structure in the river itself, most definitely.
Thank you. Thank you. We might just stick with you, Dale, because I think Paolo's just having a few technical issues. He's obviously overseas for our Q&A. And we have a question asking you, Dale, can you repair gabions damaged by floating debris? And hopefully I pronounced that correctly.
Yes, you certainly can repair them. The double twist configuration means that if one or more wire is damaged, it still has excellent strength retention properties. It really is as simple as filling, any voids with appropriate rock fill and connecting a mesh panel over the damaged area in the described, so as to not obviously reduce the structural integrity of the system.
Thank you. Thank you for that. Paolo, are you back? Are you back with us? No, maybe not. So we might just keep going with you, Dale. We have a question that is similar, that it's come in. I'm not sure who sent the question through, but it's a great question asking Dale, what size rock is recommended for Gabions and Renault mattresses? Thank you.
Well, in Australia, we are actually quite lucky in that we do have an Australian standard specifically for Gabion and Renault mattress rock infill. It's the AS 2758.4, and what they state in the standard is that the rock for Gabions should be between 100 millimeters and 250 millimeters and be sort of evenly graded. And for Renault mattresses, should be between 75 millimeters and 2/3 the thickness of the Renault mattress, or 250 millimeters, whichever is the lesser. As far as the rock type goes, it should be durable, non-friable, and not show any signs of weathering. Normally a quarry obtained type rock like a blue metal, basalt, granite, etc. is probably the most commonly used fill material. But I have seen sandstones, I've seen even recycled building rubble used. However, there may have to be additional checks on density and weathering at the end of the day to make sure that they do fulfill the life expectancy of the structure.
Thank you, Dale. And just while Paolo gets back up and running, what are the major changes and trends that you've seen in the last few years, and what do you think is coming down the pipe? Thanks, Dale.
Changes with regard to solutions, Amanda. We obviously seeing more sustainable solutions. People are a lot more in touch with nature, you can say, looking at environmental type solutions where vegetation can integrate well with the solutions that are being adopted. Fauna, flora, as long as they can, I guess, adapt to the structures that are being put in place, that's definitely a big positive. And we are seeing a big shift from those sort of hard structures that are not permeable to these more flexible permeable types are becoming definitely the flavor of the month. There's no two ways about that. It's obviously just making sure that the structures are designed appropriately and installed correctly. That's obviously a very important one with any of these river training type solutions. You've got to make sure that they are installed as per the recommendations, whether they local government recommendations or supplier recommendations. They've got to be installed correctly. It's pointless having a wonderful design, but then it's not installed as per the requirements. So very important that does happen at the end of the day.
Thank you for that. Appreciate that. And we're just having a few technical issues for Paolo. Are you back on, Paolo? So I just wonder if we just sort of look at some of those questions that came in on registration, Dale, and we had a few that were directed to Paolo. Are there any of those that you can answer? Maybe if we look at question 4 about the semi-arid regions that came in from Samari in WA.
One was regarding areas, I believe, where vegetation is unlikely to establish. Yes. Most definitely. Sorry. We've,
Yes, so maybe
yeah,
I should, I'll read you the whole question. So
sure. Yes, please.
Paula was asked, what are some solutions for semi-arid regions where imported material is limited? That came in from Samari, who's watching WA. Thank you for that question.
Sure. Well, if you are looking at the solutions that we've gone through today, and, particularly Gabion, Reno mattresses, etc., and if rockfill is hard to come by, there are ways of filling these units by using a composite of materials, having the hard, durable type material on the outside, and having I've seen a number of examples of sand filled geotextile bags placed directly behind the facing, just to provide the necessary mass and shear resistance that's required. So there are ways of accomplishing that if fill material is difficult to get, most definitely.
Thank you, Dale, and thank you for pushing on. We do have a great question that came through asking about heavy metals, and the question was to Paolo, but Dale, maybe you can have a stab at it, asking, do polymer coatings contain and release heavy metals?
I believe Paolo's back online, Amanda.
Oh, Paolo,
Am
you're
I?
just in time.
Oh,
Well
wonderful.
done.
Wonderful.
Good on.
Perseverance pays.
Thank you so much, because I've been trying, because I could hear you. I could hear you, but unfortunately you could not hear me. Okay. All right. Well, well, the question is very simple, because it's the result of say years and years of research with Polymac. Our last generation, this named Polymac, is free of heavy metals, but it's not just that. It's free of chlorinating hydrocarbons, free of pesticides, free of, and that's a very difficult word that I don't know if I managed to pronounce it correctly, polychlorinated biphenyls is one of the, and free of polycyclic aromatic hydrocarbons. So those are the say most important types of let's say I could say pollutants that are in accordance to severe standards. There's one in Europe that is mainly considered as the most severe in Germany, which is the MGEOC E216, 2016. That was published in 2016. We underwent also this kind of testing because we want to make sure that anything that we put into the water will be absolutely clear and clean. So hopefully I answered the question.
Thank you. We might stay with you, Paolo, and give Dale a bit of a rest. We've had a question, great one, that came in from Quoc, watching from Victoria, asking you, on occasion, heavy rain leads to serious flooding in large areas. In case of flooding occurrence, can the riverbank protection system still function properly? Thank you for that, Quoc.
Of course, they have to be designed that way. And in case of a flooding, the riverbank must function properly, of course. At the base of its choice, there shall always be a decision based on the risk assessment, as you have seen in the presentations, which is, of course, the analysis requires the analysis of potential risks and damages associated and beyond project assumed data. And the experience allows to help designers in this at decision-making time in this choice by considering the flood event not just as a by design, but all the implications in case the event is exceeding the project conditions assumed. So this is becoming more and more of an issue, and we hear this more often, unfortunately, due to the changes in climate and the difficulty to predict the events based on a reliable statistical envelope. And this is a problem not just in Australia, actually, but it's of a global entity.
Thank you for that. And staying with you, Paolo, and we've had questions from all around the country, which is fabulous. We're now going to Queensland, And Peter is asking the question, Paolo, I have found aging geofabric that crumbles when touched. When placing these materials into a waterway environment, how do you stop it ending up as microplastic pollution? Great question, Peter.
Good question, Peter. And in fact, geotextile in this case are on, let's say, on a relatively safer side because they're used under the Rhino mattresses or under the Gabions, so meaning under the surface. Their function is to provide a transition between the natural soil and the gravel layer of rock inside the basket. So being multiple layers of rock and not directly exposed to the air, meaning exposed to the water as well, or high, low temperatures, or like UV, etc., etc. Their degradation over time consists rather in melting with the soil underneath in a close contact, favoring in many cases the growth of a coracle layer. That's what we've experienced in say hundreds and hundreds of projects instead of dissolving or releasing their particles into the water. Although we see more and more an interest for the subject because microplastics released into the environment are a very crucial element, and it is being discussed in several countries, including Europe, of course. However, there are few research studies at the moment as we speak. And I have to admit myself that we're still at a very early stage of knowledge. Like in other cases, this gives rise to mostly opinions rather than real facts. Some are negative, some are favorable. So we hear sorts of discussion in all directions without considerations of facts or data to substantiate. And the effort that we're trying to put in, and we have some research ongoing right now, is to study this matter with experts and learn on the facts.
Thank you, Paolo. And just staying with you, we have another question from Queensland, from Arcadius, asking you, Paolo, does Micro Studio have the capability to design fish pass structures, waterway barrier works? Thank you.
Okay, thank you, Arcadius. Well, no, technically, Macra design is a tool to assist in the design. So designing, so making the choice of a structure, both from hydraulic or from static point of view, as you have seen. The fish, the fish passage is a structure which largely depend on the site conditions, and they can be different from structure to structure. So it's kind of difficult to include that into a software where we deal with, say, the hydraulics calculations, etc. It's rather an issue that it concerns the morphology, the territory. Nevertheless, we assist the designers because obviously fish passages are, say, sometimes required in river training works, and we assist the designers in the most practical ways. We've done several in multiple projects, and the suggestion in this case that I could give is to contact our nearest technical engineering team and ask for advice. We obviously, we provide this all free, always free of any obligation. There are several typical examples of fish passages that we've built around the world that might probably among them find one that could fit to your project case.
Thank you, Paolo. And Dale, bringing you back in, we've had a question come in from Lucy. Good afternoon, Lucy, asking you, can you recommend, Dale, effective tie-in methods to limit preferential erosion along the margins and failure of the mattress? Dale.
Yeah, that's a very interesting question, and it's an issue that I come across. I won't say on an often basis, but I do see every now and again. We've got to remember that concrete is obviously rigid. Rhino mattresses are flexible, and there could potentially be an issue if we're just butting them up to each other and then expecting high flow conditions. There's a good chance they will move apart, or the Rhinos will move away from the concrete. we've got to have some sort of mechanical connection between the two of them. We've fantastic details. I've got some good examples of what can happen if you don't use that mechanical connection. There's various specifications around the country. In fact, a lot of the projects coming out of the Northern Territory, because of the high rainfall they get and flood conditions that almost happen immediately, they've got quite a nice detail in their standard drawings for connecting Renos to concrete margins. But it's either done with Kempset bolts, it's done with expanding bolts with galvanized pieces of steel, whether they're ironed or bar, but various examples, and I'd be only too keen to share those examples if Lucy would like to get hold of them.
Thank you, and thank you, Del, for offering to share that with our audience, which we can do in the post email that we will send out after the event tomorrow. Paolo, a question that's come in from Sheikh asking, mattresses may trap sediments and debris, leading to sediment accumulation. How can we overcome that?
Well, sediment and accumulation is actually something that can sometimes not be detrimental. It depends really very much on the site. We've experienced, for example, that sedimentation has been something to regenerate a natural environment in underwater applications, for instance, which is one of the good things because actually what we are doing, we're favoring the sedimentation, but we leave, let's say, a sort of armoring element underneath, let's say, a thin layer of material. And this plays a big advantage. The design shall consider sedimentation sometimes as a positive, some other time as negative. And then depends on this, that the choice of the engineer has to be very careful in the decision on where and especially the location, where to place the structures. I have to say that, for example, in river meandering effects, sedimentation plays in favor again. And so the construction of groins, for example, is specifically done to favor natural sedimentation. So I wouldn't consider that as a negative effect, but I would definitely pay attention in the way that we use our structures in a proper way. Not to forget another important point. Gabions and mattresses using natural materials of a lower size compared as opposed to conventional riprap have the advantage that provide a very minimal index of voids. So the sedimentation tends to be just and only on the surface rather than inside the structure.
Thank you for that, Paula. And just sticking with you for the moment, we've had a question from Megan in Queensland. Good afternoon, Megan, asking, are there specific regulations or guidelines that govern the design and implementation of eco-friendly riverbank protection systems? And how do these differ from traditional methods? Thanks, Megan.
Sure, thank you, Megan. This is a very interesting question, and we're very much involved into this. Yes, Europe, for instance, published a few years ago guidelines in use. They are in use to provide an indication of the environmental value of a given riverbank protection over time, over the years. And this was, for us, an excellent project because through the cooperation of experts in this field, we were able to implement these guidelines in a user-friendly software. Its name is Requalife. And I had the pleasure to present a paper about a year ago at an international conference in China. It received, say, much of an attention and interest from the audience. And if you are interested in having more details, you have to really definitely stay in contact with us. Contact our nearest technical office. I'll be more than happy to share this experience. And if you are interested, also give you access to the software. As it's another web app. It's part of our, say, design platform.
Thank you, Paolo. And staying with you, we've had a question from Fu asking, how does the research evaluate the stability of revet mattresses in relation to their thickness and stone size? And what are the implications of this evaluation for erosion control in open channel? Thank you for that question.
Well, sure. Thank you for the question. Yes, you have partially seen this, and it was for brevity of time. I could not get into much more details on the test and the research at Colorado State. It was extremely important, and it was for us a learning lesson, I have to say, because when you are testing a product under a very heavy, say, streaming high flow, there are effects of the turbulence that sometimes cannot be caught by simple or scale model testing. That was an interesting aspect also because one of the things that we did not expect was how important the uniformity of the rock inside the basket play an advantage in terms of resistance. So all in all, the research enlightened us on what are the crucial parts. I have we have, let's say, webinars done on the subject and especially getting more in the details of this research. If you're interested in seeing a little bit more how this correlates to, especially to open channel design, again, I can only suggest to stay in contact with us because there is so much information that we can make available, and where I'm sure you will get, say, most of probably of the answers to your question.
Thank you, thank you. And I've just got a couple more questions for you, Paolo, and then we will I'll ask you to both give the key takeouts from your presentations. But the first question, Paolo, is come from Ashar asking, is the Macra software engineered for large water bodies only, or can it be implemented for smaller drainage channels, also more commonly encountered in urban environments? Thanks, Paolo.
Absolutely, and thank you. Sure, the software can be adapted to any sort of water courses, from artificial drainage channels to larger rivers. In what actually is for the smaller channels, the work to do is actually very limited because you have to do just taking a template and choosing the shape, the geometry that mostly fits to your channel case, and then just adjust the sizes and sloping angles, etc. If it's a trapezoidal, you could basically, the templates help you in facilitating your work, but you technically can do anything, even I would say a schematic of a circular section, just playing numbers with reducing the base, the width, and to 0, and then changing slopes in a sort of polygonal cross section. So yes, the answer is yes, and of course, if you'd like, you can do it two ways. One is register yourself and play a little bit with our web app. See if you come, easily to your answer, or otherwise contact us. And like I said, we offer tutorial sessions, and they are free of any obligations to all our people. You just need to register with your email address, and then we will get back to you in time. But like I said, registering to our web app is another free thing that you can do anytime.
Thank you. Thank you for that. And Paolo, final question to you from Omar asking, from an environmental perspective, can marine creatures use the voids within Renault mattresses for protection?
Do you hear me? I lost
Yes.
you.
No, I can hear you.
Hello?
Hello? Okay. Dale, we might just move back to you. We've covered a lot this
Can you hear
afternoon
me?
talking about. Yes, we can hear you. Can you hear us? No. Maybe Dale, I might just throw it back to you. We've covered a lot this afternoon talking about eco-friendly riverbank protection systems. And I just wondered, Dale, if you could sum up the key takeaways from your presentation to leave our audience with.
Well, I guess we really understand that hydraulic structures are highly engineered, and they require, if possible, a hydrological study or analysis to obviously ensure that they perform their functions and can withstand the changes in climate and flood conditions due to urbanization and flow conveyance in a channel because of the establishment of vegetation. As I said earlier, we are finding more and more interest in these sorts of eco or type solutions rather than traditional hard concrete type solutions. Where we can integrate within the environment and obviously fulfill the design requirements and the longevity is I guess something that we've got to aim for, something that's functional, but something that blends in well with the environment. That's ultimately what we're trying to achieve at the end of the day.
Thank you. And Paolo, do you want to sum up? Or maybe we might have still lost you. So we might wrap it up there because it is all actually time we have for today. And please join me once again in thanking Dale Chachak and Paolo Di Pietro for their time and input. I'd also like to warmly thank Engineers Australia's industry partner, Geofabrics, for their support. Quickly, I'm excited to announce Engineers Australia 2024 Climate Smart Engineering Conference. Early bird red Joes have just been launched, so get in quick and please follow the QR code on your screen for more information. As always, if you could take a couple of minutes to please complete a short feedback form, which is linked in the description box below, helps us improve and plan for future sessions. Thank you again for joining us, and I look forward to seeing you at our next Thought Leaders event. Thank you and good afternoon.